Hi, I'm Navjeet Singh, and you're watching BIOnTips, where we simplify business intelligence step by step. In today's video, we are going to learn one of the most important concepts in Power BI, data modeling. Now, many beginners spend most of their time creating charts, graphs, and dashboards, but experienced Power BI developers know that the real work starts before you build a single visual. A well-designed data model makes your reports faster, cleaner, easier to maintain, and much easier to scale. So in this video, we'll understand what data modeling is, what fact and dimension tables are, what a star schema is, and why companies use this approach, and some important best practices you should follow. So let's get started. Imagine you are building a house. Before you start painting the walls or choosing the furniture, you need a strong foundation. Data modeling works in a similar way in Power BI. Data modeling is a process of organizing your data into related tables so that Power BI can analyze that data efficiently. So instead of putting all your information into one huge table, we divide the data into logical tables and connect those tables using relationships. This approach improves report performance, makes DAX calculations easier, and makes the overall Power BI solution much easier to understand and maintain. So now let's understand why data modeling is so important. Imagine that you have created a Power BI report using one very large table containing customer, products, stores, dates, sales, and many other pieces of information. So it might work when you have a small amount of data, but as your data grows, problems can start appearing. So your reports may become slower, your DAX calculations may become more complicated. You may have a lot of duplicate information which can increase the size of your Power BI model, and most importantly, maintaining that model can become difficult. So a good data model helps solves many of these problems. It can provide better performance, faster data refreshes, simpler calculations, and a solution that is much easier to scale. So that's why in real world Power BI projects, data modeling is usually given a lot of attention before the dashboard itself is built. Now let's talk about the most important table in our model, the fact table. A fact table stores measurable business events or transactions. So for example, think about a retail company. Every time a customer purchases a product, a transaction takes place. So that transaction can be stored in a sales fact table. So other example of fact tables include orders, transactions, revenue, inventory movement, or website activity. So typically, a sales fact table might contain columns such as order ID, product ID, customer ID, date, quantity, and sales amount. So each row generally represents a business event or transaction. So an easy way to remember a fact table is this. A fact table tells us what happened. For example, what was sold, when was it sold, to which customer, and for how much. Now that we understand that what are fact tables, so let's move on to the dimension tables. Dimension table provides descriptive information about the data in our fact table. Common example are product, customer, store, and date. These tables help us answer questions such as who, what, where, and when. For example, our customer dimension might contain customer ID, customer name, city, and customer segment. Our product dimension might contain product ID, product name, category, and brand. And our date dimension might contain date, year, month, and other calendar attributes. One important benefit of dimension table is that we don't need to repeatedly store the same descriptive information in every transaction. So for example, instead of storing a customer name thousands of times in our sales table, we can store the customer information once in a customer dimension and connect it to the sales table using customer ID. So this brings us to one of the most important concept in Power BI data modeling, the star schema. In a star schema, we place the fact table in the center, then we connect our dimension tables around it. For example, we might have a fact sales table in the center connected to dim customer, dim product, dim store, and dim date. The fact table contains the key and the measurable values, while the dimension table contains descriptive attributes. When you look at the model visually, it starts to look like a star, and that's where the name star schema comes from. So this structure is widely recommended for Power BI because it makes the model easier to understand, improves performance, simplifies filtering, and generally makes DAX calculation easier to write and maintain. Now let's understand relationship. Relationships are what connect our fact and dimension tables together. For example, customer ID connect our fact sales table with the dim customer table. Product ID can connect fact sales with dim product, and date can connect the fact sales with a date dimension. Hence, these relationships are correctly configured. Power BI can answer questions such as how much did we sell by product, how much revenue did we generate by region, how did sales change month by month, and we can answer these questions without having to duplicate all of that descriptive information inside our fact table. Now look at some common mistakes that beginner make when creating Power BI data model. First mistake is importing one huge flat table and trying to do everything from that table. Second mistake is creating unnecessary bidirectional relationships. Third is using many to many relationships without fully understanding when and why they should be used. Another common mistake is keeping duplicate columns throughout the model. And finally, many beginners skip creating a proper date table. So these mistakes can make your model more complicated and can lead to performance and calculation issues later. So what are some best practices you should follow? First, whenever possible, use a star schema. Second, keep your fact tables narrow and focused on business events. Third, create a dedicated dimension table for descriptive information. Fourth, hide technical key columns when they are not needed by report users. Fifth, use meaningful and consistent tables and column names. And sixth is create a proper date table for time-based analysis. And finally, avoid creating unnecessary calculated columns when a measure or a better modeling approach can solve the problem. So these practices are commonly used when building a scalable Power BI solution in enterprise environment. So let's quickly summarize whatever we have learned today. Data modeling is the foundation of a successful Power BI solution. Fact tables store business events and measurable values. Dimension tables provide descriptive information. Relationship connect these tables together. And the star schema provides a clean and scalable structure for Power BI models. When you get your data model right, writing DAX becomes easier, your reports can perform better, and your solution becomes much easier to maintain. If you found this video useful, don't forget to like the video and subscribe to BI on Tips for more content on Power BI, business intelligence, data analytics, and automation. And if you know someone who's learning Power BI, share this video with them. Thanks for watching, and I'll see you in the next video.